A very good morning and welcome back to the course of microwave engineering. Now today in this particular lecture we will be starting with the last module, that is microwave integrated circuit. In the previous lecture we have successfully completed the measurement of all the different types of microwave parameters. Now we have seen the total different 9 microwave parameters we have covered in our previous lecture. So from today we will be beginning with our last module, and that is microwave integrated circuit. And this module is a small module in the prescription of the syllabus, and it will take a couple of lectures in order to fully complete this last module. And thereafterwards the entire syllabus of microwave engineering will be ended. So today we'll be starting with the last module of the syllabus under the microwave engineering subject, that is microwave integrated circuit. Now in this particular module we are going to see briefly the different technology that is being implemented in order to fabricate the microwave circuit and microwave devices and even systems by making use of integrated circuits. The integrated circuits which is available at the lower frequency in digital electronics is analogous to microwave integrated circuit. The same type of a fabrication technique, the way in which we are going to make use of different types of operation in the manufacturing of digital integrated circuit, the same type of a manufacturing processes are involved in the construction and design of microwave integrated circuit. But here there is a little difference between the microwave integrated circuit and digital integrated circuit, the way in which they are going to operate. Now, as far as microwaves are concerned, the main consideration for the design of integrated circuit is its high frequency operation. So typically the microwave integrated circuits are designed to operate in the microwave frequency range up to several gigahertz, up to 60 to 70 gigahertz, right? And these microwave integrated circuit we are going to study in this particular module. So first of all, we will see the general properties of the microwave integrated circuit, the historical development, and then we will classify the microwave integrated circuit into its two types, hybrid and monolithic type. So without wasting time, let us start with the chapter microwave integrated circuit, module number 6. So here in front of you, these are the notes which are prepared by me, and I will be starting explaining you the concept of microwave integrated circuits. First of all, the microwave integrated circuit, the abbreviation we are going to make use frequently is capital MIC. Okay, so the use of microwave integrated circuit facilitate us the microwave technology in order to improve towards making smaller dimension, lighter weight and lower cost and increased complexity devices and circuit. Okay, so the use of microwave integrated circuit helped us in order to fabricate microwave devices, systems and circuit with these type of a feature. So we are able to make them very small in size, they can be made lighter in weight, and the cost of production is also reduced, and all these advantage we are getting with the benefit of increased complexity. So all these advantages of fabrication of microwave devices and circuit by making use of integrated technology helped us to improve a lot more. Okay, the use of microwave integrated circuit, it serves to replace the bulky and expensive waveguides. This is an important statement, and coaxial components. Okay, so earlier when before the development of integrated circuit, the microwave devices were constructed using bulky and heavy waveguides and coaxial components. Okay, but with the development or the evolution of microwave integrated circuit, these bulky expensive waveguides and coaxial components can be replaced by using planar type of a circuits. Okay, so all these components, that is the three-dimensional waveguides and all those things, these can be replaced with inexpensive planar components. So this is the biggest advantage that the integrated circuit technology is going to offer us, okay, with which we can completely replace this type of a component by using planar printed transmission lines, right? Microwave integrated circuit are analogous to digital integrated circuit. I already told that whatever the low frequency digital integrated circuit that we already know, the microwave integrated circuits are analogous to the same. Okay. Only the difference is that the microwave integrated circuits are constructed and designed to operate at several gigahertz, right? The microwave integrated circuit can incorporate transmission lines. So we can design transmission line using integrated circuit. We can design discrete resistors, capacitors and inductors along with active elements like diodes and transistor also. Okay. So integrated circuit in microwave technology we can make use in order to fabricate not only the transmission lines, not only the passive devices, but also we can fabricate active elements like transistors and diode. Okay, so with the help of integrated circuit technology, we can fabricate the conductors in the form of a transmission line, especially these are in the form of a printed circuit board. Okay, the passive devices including all resistors, capacitors and inductors, as well as the active element which are normally the diodes and transistor, they all are constructed using this integrated circuit technology. The today's microwave integrated circuit technology is advanced to the scale that entire microwave systems like RF front end and receiver, radar transmitter and receiver modules, they can be developed using a single chip of few millimeters square in size. Okay, so with this particular statement you can understand the expandability and the scale of usage of the microwave integrated circuit in the microwave technology. Okay, by using integrated circuit today it is possible for us to construct entire system, particularly a micro system, for example RF front end receiver, radar transmitter and receiver module even. Okay, all these micro systems can be entirely fabricated on a small chip which merely measures few millimeters square in size. Okay, so today's integrated technology is sophisticated and improved up to this extent. Okay, so this is the biggest advantage that we are going to get, and all the bulky component and all the tube like of structure, the sources, they can be conveniently replaced using this type of a technology, right? So the microwave integrated circuit, now we are going to see the classification. Now broadly the microwave integrated circuits are classified into two types. First of all, the hybrid microwave integrated circuit, or we call it as a HMICs, and second is a monolithic microwave integrated circuit, we call it as a MMIC. Okay, so there is a difference. Now we are going to study what is the difference between the hybrid microwave integrated circuit and monolithic microwave integrated circuit, right? Now here the basic difference is mentioned over here. The hybrid microwave integrated circuit makes use of single layer of metallization. See, this is important for conductors and for transmission lines. And the discrete components like resistors, capacitors, transistors and diodes are bonded to the substrate material. Okay, so the classification of microwave integrated circuit into two types, there is a hybrid type and monolithic type, is based on the principle of construction technology, right? So the construction technology for the hybrid microwave integrated circuit is that it makes use of single layer of a metallization, and this metallization layer is only used for fabricating the conductors and transmission lines. Okay, and the other components like passive elements and active elements, they are actually soldered, okay, or it is bonded to the substrate material. Okay, so here we should remember that in hybrid microwave integrated circuit only one layer of a metallization is used, and this layer of metallization is used for fabrication of conductors and transmission line. And the other devices, including your passive devices and active devices, these are actually separately bonded to the substrate. Okay, so this is what the construction technology of hybrid microwave integrated circuit. Now, by making use of thin film hybrid, simple components can be deposited onto the substrate, but this is an optional process. Usually a single metallic layer is used, and this metal layer is only used for the purpose of serving as a conductor or the transmission line, and all the remaining component, that is the passive devices and active devices, will be actually bonded to the substrate. Right, now let us see what is the difference in the monolithic microwave integrated circuit. Then in monolithic microwave integrated circuit, it integrates active and passive circuit elements directly grown onto the substrate. Okay, so this is the difference, basic difference as per construction point of view between hybrid microwave integrated circuit and monolithic microwave integrated circuit. Right, in monolithic microwave integrated circuit, all the active and passive circuit elements are not bonded as a discrete element, but they are grown inside the substrate itself. So that's why entire thing is fabricated from the substrate, and that's why the name is given as a monolithic. The meaning of monolithic is that everything is fabricated from the substrate itself. Right, so the substrate is the semiconductor material. Right, so here whatever substrate that we are going to make use of is a semiconductor material. Okay, and the biggest difference between the monolithic and hybrid microwave integrated circuit is that in monolithic microwave integrated circuit we may use lot many layers of metallization. Right, but on the other hand, in hybrid microwave integrated circuit, we are going to make use of only single metallization layer. Right, so this integrated circuit makes use of several layers of metals, several layers of dielectric and resistive film for the construction wise. And as far as construction is concerned, monolithic microwave integrated circuits are complex compared to the construction of hybrid microwave integrated circuit. So why the name hybrid is given? Hybrid name is given because the transmission line and conductors are fabricated from the metallization layer, while the other active and passive components are directly bonded to the substrate. So that's why this is a hybridization. So that's why these type of integrated circuit we call it as a hybrid microwave integrated circuit. On the other hand, in the case of monolithic microwave integrated circuit, everything is constructed from the substrate, and here we are going to make use of multiple layers of metals, dielectric and thin resistive films also. And construction wise, monolithic microwave integrated circuits are complex compared to hybrid microwave integrated circuit. Okay, so let us go into the details how a typical hybrid microwave integrated circuit look like. Right, so in front of you over here, the diagram illustrates a typical construction layout of microwave integrated circuit. Okay, so here everything is denoted over here. Now we have a slab of a semiconductor. Now this semiconductor is bonded with the metallization layer at the ground plane. The back side of this substrate material is coated with a metal, and this metal layer on the back side is acting as a ground plane. Right, and over to the substrate we again have a printed element. Now this pattern is a printed element. So here I will write this is a printed element, and this printed element is usually constructed using a microstrip line, or microstrip technology is used to fabricate these lines, microstrip techniques I write here. So whatever the artwork that you observe over here with the dark color, that is a printed element. and this printed element is present on the opposite side of the substrate. Okay, and this printed element usually serve as a transmission line and conductors. Okay, and this printing technology is achieved with the help of microchip technology. Right, now here we also observe that discrete components including passive element and including active elements like inductor, capacitors, resistors, right, transistors, all these are directly bonded over the substrate. So actually substrate is this particular material. So here I will denote with a different color. So this is a substrate. This is a substrate, right? So this substrate material, on the top side we have our actual circuit. In the actual circuit we have the transmission lines, and these transmission lines are in the form of a printed technology. Okay, so whatever dark colored line or layout that we observe in this particular diagram, it is nothing but a microchip transmission line. Okay, and the discrete elements like chip capacitor over here, okay, field effect transistor as an active element, okay, the inductor as a passive element, all these components are directly bonded to the transmission line over the substrate, right? So this is a typical construction of hybrid microwave integrated circuit, how it looks like, right? The diagram is clear. Okay, so I will go through this particular description. The material selection in the case of hybrid microwave integrated circuit is very important aspect, because the selection of a particular material for the construction of hybrid microwave integrated circuit is going to play a very important role. Okay, for example, in hybrid microwave integrated circuit, alumina, okay, quartz and Teflon fiber are most commonly used substrate material. So as an example of substrate material in the construction of hybrid micro integrated circuit, the best choices are to make use of alumina, quartz and Teflon. Okay, now why these particular materials are used for fabricating the substrate for hybrid micro integrated circuit? Because if you observe their dielectric constant, the dielectric constant of all these substrate material is very high. Okay, high values of dielectric constant for the selected material is always desired, because as it result in smaller size of the circuit at lower frequency operation. Okay, we already know that in the construction of integrated circuit we are going to make use of a substrate which consists of high dielectric constant. The high dielectric constant will help the propagation field over the transmission line in order to retain inside the transmission line and minimize the spurious radiation. So that's why the substrate which possess this particular property we need to select in a such a way that they should have high value of dielectric constant. Okay, substrate thickness is also selected in order to reduce the radiation loss and spurious effect caused due to the thickness. Okay, so the thickness of the substrate material is also a critical factor in order to design the hybrid microwave integrated circuit, because the more is the thicker of the substrate, more will be the radiation loss and spurious radiation or spurious effect. Okay, computer aided design tools are extensively used for the design process, optimization process, layout and the mask generation. Okay, so the mask generation is a typical process in integrated circuit in which a blueprint of the circuit which we want to fabricate using the integrated circuit is prepared. So mask refers to the blueprint of the circuit which we want to construct using the integrated circuit. So the mask generation, layout generation, optimization and design, all these works can be accomplished using sophisticated computer aided tools like Cadence, Advanced Design System and Microwave Office. So these are the names of few microwave design automation and computer aided design tool which are commonly used in this processing of microwave integrated circuit. The circuit mask is made on the soft mylar type of material for high accuracy. The metallized substrate is coated with photoresist material which is covered with a mask and exposed to the light source. So this is just the way in which this particular material for hybrid microwave integrated circuit is utilized for the construction. The substrate is then aged to remove the unwanted areas of the metal. Okay, so it is similar to the process of PCB making, right? So the material which we want to etch out, that is exposed to the radiation, and whatever exposed part of the circuit, that will get etched out. Okay, and whenever we want to connect a particular circuit discrete element to the micro transmission line which is printed over the substrate, we need to make via holes and connections, and these plated through and via holes can be made by evaporating a particular metal layer inside the hole that has been drilled into the substrate. The discrete components then later on they can be directly soldered or bonded to the conductor material along with the substrate, and this fabricated hybrid microwave integrated circuit is then used for testing purpose. So this is a typical construction wise the description of hybrid microwave integrated circuit. The thing that we need to remember over here is that only single layer of metallization is used. Okay, one metallization is acting on the opposite side as a complete ground plane, and on the other side of a substrate whatever metallization that we use, that is more or less it is used as a transmission line or conductor. Okay, and these transmission lines and conductors are connected with active and passive devices which are directly soldered on or they are directly bonded on the substrate with these conductors and transmission line. Okay, so here whatever I encircle, so these are the passive and active elements that we are going to directly bond over the transmission line using substrate material. Okay, so this is all with respect to hybrid microwave integrated circuit. Now let us proceed with how differently the monolithic microwave integrated circuit look likes. Okay, so here on my right hand side whatever picture that we observe, that is a typical construction layout of monolithic microwave integrated circuit. Okay, so if you merely observe this particular diagram on the right hand side, you can directly find out the complexity of design. Okay, now here in the case of monolithic microwave integrated circuit, we are going to make use of several layers of metallization, several layers of dielectric and thin resistor films. For example, over this particular section, we will find several layers of metal, right? Now below here also we will find a metallization layer which is normally acting as a ground plane, right? And here this is a particular substrate. So the substrate I will show with a different color. So this is our substrate, and everything, okay, including your active component and passive components are fabricated by growing them directly through the substrate. So this is a substrate. Okay, so here I write substrate. Okay, so this is how typically it look like. The substrate is backed by the metal ground plane, and over also we are going to make use of several layers of metal, several layers of dielectric even, right? So here the typical example of active devices, the field effect transistor over here it is shown. So this is a typical field effect transistor, how it look like. It is grown, so this is a typical source, gate and drain terminal of that field effect transistor which is directly grown into the substrate. Okay, and implanted resistor is shown over here. This is an implanted resistor. This is one of the example of passive device. Okay, and the material which we typically used in the fabrication of monolithic microwave integrated circuit is gallium arsenide, right? And on the other side of substrate, we have all these design of components. Okay, so the microstrip transmission line, whatever this dark color line we observe over here, that is a conductor, and this conductor is fabricated by making use of a microstrip technology, right? And here we have the bridge circuit. Okay, and we can have the passive devices like monolithic integrated microwave capacitors. Okay, and everything for the making of the connection and all the vias are drilled through the substrate material. Okay, and the vias are made such that the metallization layer is going to get surrounded over here. So this seems to be very complex in structure when it is compared to hybrid microwave integrated circuit. So let us go through this. In this particular integrated circuit, all the active and passive components which are required in order to design a circuit are grown or they are implanted directly in the substrate. So this statement is very important. Okay, so this feature is unlike hybrid microwave integrated circuit, in which the active and passive devices are bonded externally to the substrate. Okay, but instead of that, in the case of monolithic microwave integrated circuit, the active and passive elements are directly grown from the substrate material itself, right? The substrate used for the construction is a semiconductor material which will accommodate the fabrication of all the active components. Okay, so the material for substrate, the choices are the silicon on sapphire and gallium arsenide are the two best choices of semiconductor material which are used for the fabrication of monolithic microwave integrated circuit. Okay, and this semiconductor material can be used up to 60 gigahertz of operational frequency range, right? The transmission lines and other conductors are made using gold layer metallization, and insulating dielectric material layers are made using the materials like silicon oxide and silicon dioxide, okay, for capacitor and all those things. The resistors are made with lossy films of nickel chromium, tantalum, and so on. Okay, monolithic microwave integrated circuit design requires extensive use of CAD software for the circuit design, because unlike the few metallization layer, single metallization layer in the case of hybrid microwave integrated circuit, the design of monolithic microwave integrated circuit involves making use of lot many layers of not only metal but dielectric and thin films which are going to form a resistive element, right? So that's why extensive use of microwave CAD tools are required for the design, optimization, as well as the mass generation process is very complex compared to hybrid microwave integrated circuit. Okay, once we finalize the circuit design, then we can fabricate the appropriate mask. Okay, I already told the mask is the entire blueprint of the circuit which we want to fabricate using this integrated circuit technology. The process begins by forming the active layer in the semiconductor substrate for the active devices. So how the active device is constructed using the substrate? The active devices are fabricated by forming the active layer in the semiconductor substrate in order to develop the active element, and this is accomplished by a process known as ion implantation technique. Okay, so a typical active element, for example diode, transistor, these are fabricated by using the substrate itself, okay, by means of a technique called as a ion implementation technique. Ohmic contacts, okay, with the transmission line and conductor, they are made to the active devices by making use of alloying of gold layer onto the substrate. The first step of the metallization for the contact and the transmission line and inductor is performed. Okay, and in the second layer of metallization, that is mainly used for development of capacitor and overlays, right? And the final step is required in order to maintain the required thickness of the substrate material and in order to maintain the position of the via holes, which are formed by directly etching and plating process. And the individual circuits on the wafer are then cut and then they are tested individually. So typically the construction wise monolithic microwave integrated circuits are very complex in comparison to hybrid microwave integrated circuit. Okay, so these are the two, just a brief explanation that how the hybrid microwave integrated circuit and monolithic microwave integrated circuit look like, and construction wise how they are going to be different from each other. Okay, so let us have a comparison in brief between these two different types of integrated circuits which are used in microwave technology, right? So on my left hand side I have listed out the distinguishing parameters of hybrid microwave integrated circuit, and on the right hand side I have listed out the distinguishing points for monolithic microwave integrated circuit. So one by one let us go through these particular points, right? First of all, in the case of hybrid microwave integrated circuit, we know that a single layer of metallization is used. Okay, please remember, single layer of metallization means a ground plane metal which is located on the bottom of the substrate, and on the top of the substrate we are only making use of a single layer of a metallization, and this layer of a metallization is used in order to fabricate the conductor and transmission line only. On the other hand, if we compare the monolithic microwave integrated circuit, multiple layers of metallization are used. Okay, so anyway the substrate is backed with a conductor, so that metallization is a separate, and on the other side of a substrate we are not just restricted with using single layer of metal, but several layer of metal can be used in the case of monolithic microwave integrated circuit. The next point of discussion is the discrete devices, okay, in the form of active and passive element, resistors, capacitor, diode, transistor. They are taken separately and they are directly either soldered or they are bonded to the substrate to the transmission lines in the case of hybrid MIC. On the other hand, in the case of monolithic micro integrated circuit, all the active element and passive elements are grown by using the substrate itself. Especially we discussed how the active element is developed using the substrate using ion implantation technique, right? So next distinguishing point is controlling component tolerance values is a very easy task in the case of hybrid MIC. Now this feature is available because construction wise the hybrid micro integrated circuits are simpler to construct. On the other hand, monolithic micro integrated circuit exactly controlling the tolerance value of the developed active element or passive element is difficult to maintain, because here they are not bonded externally but these are grown into the substrate itself. So that's why precisely controlling the tolerance values of the developed active element or passive element is very difficult to maintain in the case of monolithic integrated circuit compared to hybrid circuit. The hybrid microwave integrated circuits are less expensive than monolithic microwave integrated circuit, and similarly construction wise, as monolithic microwave integrated circuits are complex, they are going to be much more expensive than hybrid. Hybrid microwave integrated circuit can be used for circuits which requires more than moderate power. Okay, so here the advantage of hybrid microwave integrated circuit is that these circuits can be used whenever we do require power more than moderate level. On the other hand, monolithic micro integrated circuit cannot be used whenever the power requirement of the operation of the micro circuit requires more than the moderate power. So that means monolithic micro integrated circuit are suitable for only low power operation and up to few moderate levels of power operation, but definitely they are not suitable to exceed the power level which is greater than moderate level, right? High resonant circuit, high Q circuit and filters can be easily fabricated using hybrid MICs, while high Q circuits, resonators and filters cannot be fabricated using monolithic micro integrated circuit. So this you can say second limitation of microwave integrated circuit in monolithic case. Circuit performance and flexibility are good in the case of a hybrid MICs, while circuit performance flexibility are best when they are fabricated using monolithic micro integrated circuit. But for that we need to pay for extra cost because the design involves complexity. Parasitic effect and reactances are more in the case of hybrid MIC. So this you can say as one of the limitation of hybrid MIC, because whatever the other elements are there, that is active elements and passive elements, these are externally connected to the integrated circuit, and that's why they may include the effect of parasitic effect and they may include excessive unwanted reactance effect in the circuit, while these effects are not severe in the case of monolithic micro integrated circuit, right? And finally, hybrid micro integrated circuit can be designed with only lower bandwidths of operation, while everything is constructed using the same substrate, and that's why this particular construction feature facilitate to make use of monolithic microwave integrated circuit to higher operating bandwidths. Okay, so all these are the distinguishing points between the hybrid microwave integrated circuit and monolithic microwave integrated circuit. Okay, so these two types or classification of microwave integrated circuit, they are good at their position as on when the requirement is concerned. Okay, so whenever we want to have less complexity in the construction, as well as whenever we want to develop the integrated circuit with lower cost, inexpensive situation, at that particular case one can go ahead fabricating the integrated circuit for the microwaves using hybrid technique. On the other hand, when we want a precise operation, okay, and if we are ready to pay for that extra cost for getting the complex design, then one can opt for the design of microwave circuit using monolithic integrated circuit technology. Okay, so here in this particular brief lecture we saw the introduction to the integrated circuit, how integrated circuits are going to help us in the case of design of micro circuit devices and even the entire system. Okay, so nowadays our technology is advanced to up to several way that we can fabricate the entire microwave subsystem over a chip. Okay, and this chip can be fabricated using several different techniques like hybrid technique and monolithic technique, and we saw in detail the comparison between hybrid microwave integrated circuit and monolithic microwave integrated circuit. In our next lecture we will go into the details of microwave integrated circuit and we will explore the other feature of microwave integrated circuit. Thank you very much and thank you all.